Review. Review sheet 4. Anything that we need to take one more look at before we take our test. Now on Monday, I think we have class on Monday.
We do.
But we will be starting, since it's virtual, we're not testing, so we'll be starting the next unit. So this is it for review, people. So review 4, or review sheet 4, what on here do we need to look at? Number 18. So do you want, there's 3 of them there. You want to do A, B, or C? A looks like one we did. But we can do A. Is that one you want to do A? C? B? Alright, let's do B. So it says tangent equals 1/5. Now, note the directions. I am solving between 0 and 2 pi, which means my calculator needs to be set in radians. Okay? So my calculator is in radians. Alright? So, here we go. How do I find the angle on my calculator? Easy. Second tan, yep. So second tan or inverse tangent, 1/5. And it is going to give me an answer. But that is not the only answer, because it looks like we get about 0.20. So clearly, I can have, that's a 0.20. I can have that in quadrant 1. So I have a 0.20 angle in quadrant 1, and that is one of my answers. Where will the other answer be? Where else is tangent positive? Yes, Josh, it's positive in quadrant 3. Why is tangent positive in quadrant 3? Because opposite and adjacent are both negative. So I have my 0.20 angle also in quadrant 3. The measure of that angle, remember I'm in radians, so please don't say 180 plus 0.2. It would be pi plus 0.2, right? Pi plus 0.2. So that is 3.34. So my 2 answers are 0.20 and 3.34. All right, Jesus, was that you that asked about that? All right, does that take care of it for you? All right, Ellie?
26, number 3.
26, number 3. We have a ship sailing from port. So this is going to be a compass problem. So I set up my compass. Here's my port. And he's going due north at a speed of 12 miles an hour for 2 hours. So that's a 24. Due north, 24. Then he's going to turn due west. So I'll do that in a different color. It's the second leg of his journey. He's going to turn due west. So that's going to be a right angle right there. I don't need to figure that out. It's going to be a right angle because northwest. And now he's going 13 miles an hour for 1 hour. So that is going to be 13. And then he's done, and I want to know the distance and direction from port. So this will be his distance, right? And now I need his direction. Now, I need that also. This will be his direction. This angle right here will be his direction. Remember, on the compass, we start at 0 and go this way, right? All right, so I think finding the length is gonna be easy, finding his distance is easy. That is a right triangle. So I can just do my Pythagorean theorem. So 13 squared plus 24 squared, and then I'll square root that. So 27.29 miles. So his distance is 27.29 miles. All right, does that make sense to everybody? Now his direction is going to be the purple angle. Well, I'm not going to be able to find the purple angle, but I think I can find this one, right? So I'll call that theta. How can I find theta? Tan, with the tan, that's exactly right. So tan theta equals 13 over 24. Tangent theta is opposite over adjacent. And then how do I solve that equation? Second tan. So, wait, I gotta be in degrees. Go back to mode, click over to degrees. You really gotta pay attention to that, a lot of switching back and forth. So second tangent, 13 divided by 24, and that's 28.44. So theta is 28.44 degrees. If you said that as his course, you would be wrong. Because if you send a ship out on a course of 28.44, he's going out here, right? We want him to go this course, so how will I find my actual course then? 360 minus that, yep. 360 minus that, so 331.56. So this course is 331.56 degrees. Okay, Ellie? All right, who else has one? Good questions. Review sheet 4. What else?
Number
10. Find the area of the shaded sector. You've got options on this. Well, you have options on every problem, basically, but you definitely have options on this problem. We have a sector. The angle is 100 degrees, and the radius is 6. And we want to find the area of it. Now, my preferred way is still to, this is my personal favorite way, you don't have to use it, but I know that the area of the whole is 36 pi, because the area of a circle is pi r squared, right? So if I ate that whole pi, I would be eating 36 pi square inches, or whatever the unit is, right? But I'm not eating the whole pie. I'm only eating a chunk of it, right? I'm not eating half of it. I'm not eating a fourth of it. I'm eating 103/60ths of it. Would you agree with that? So that means I'm basically eating 5/18ths of the pie. So I'm eating 5/18ths of 36 pi. So I can multiply straight across, or I can cancel. 18 does go into 36 twice. So the answer is 10 pi. Is there a unit on that? No, but if there were, it would be like inches squared or something.
No.
Does that make sense to you? All right. Who else?
We try number 20.
20.
Sir.
What is the period of this function? Well, this requires you to think a little bit about what impact taking the absolute value has on a picture. Okay? Now we all know that a sine curve, just a regular standard old sine curve, looks like this, and its period is 2 pi. And its amplitude is 1. That's a regular curve. Now, who remembers what happens when you take a picture and you take the absolute value of it? What does taking the absolute value of the picture do? It makes everything positive, right? It's what we called bottoms up. So the absolute value picture is going to look like this. Would you agree with that? Now, the period of that is not 2 pi. Remember, period is the chunk that repeats. Isn't the period of this just pi? Isn't that what repeats when you do the absolute value? Now, will picking it up 1 change that period at all? No. So the period is pi. Because when you take the absolute value of the sign, when you bump it up, then you're not getting a hill and a valley anymore. You're just getting hills. All right, who else? You can cross off 21. We didn't talk about that. For your own reference, in case you ever see it, this is the other notation. In calculus, they might talk about the arc functions. I don't know. But when the calculators became the way to go, they didn't use this notation anymore. They use this notation now. So you can cross that off. Not going to ask that question. All right. What else? Which one? 22a. Find the exact value of the angle whose tangent is negative √3. Remember, this means the angle whose tangent is. So, there is one answer to this question. You have to know the rules. When you see this notation, you know there's one answer. If this is positive, the answer is in quadrant 1. But it's negative. What is the rule for an inverse tangent negative number? Quadrant 4. Remember, 3 of the inverse functions are negative in 4, and 3 of them are negative in 2. Go back and review those rules. Okay, so I know the tangent is negative √3 over 1. So if we're doing this without a calculator, that better be special. Well, it is. What angle is across from the √3? 60. So if I were answering in degrees, I would say negative 60 degrees. If I'm answering in radians, I would say negative pi over 3. Right?
Will it tell us on the test whether it's in radians or
Yep, and if it doesn't, then I have to take either answer.
Okay.
Okay? All right, who else? Good questions. Who else?
Your number 8.
8. If the sign is this and that, find the value. Okay, this is one of those where you have to fill in the whole list. So we have to fill in sine, cosine, tangent, cosecant, secant, and cotangent. And they have to give me something, so what did they give me? Oh, I'm using thetas, they use dex. Sorry about that. They tell me I am between 180 and 270, so what does that tell me? I'm going to draw my triangle, and it's going to be in the 3rd quadrant. Because remember, our normal trigonometry labels are these. Please don't get that confused with the compass. This is the way trigonometry works. And they tell me that the sine is negative 3/4. Opposite over hypotenuse. So the sine is negative 3/4, which means the cosecant is negative 4/3. So those are given. This is the picture. Remember, when you draw your triangles, the hypotenuse is never negative. This will never be negative. These can be negative. And in fact, they are both negative in this quadrant, right? But I need to figure out what that one is. Some of you are going to see the 3 and the 4 and say, oh, it's 5. No. A squared plus B squared equals C squared, right? So it's A squared plus 9 equals 16. So that is negative root 7. Be careful. Don't get trapped just because you recognize some numbers. All right, so once you have that done, then you can fill it in. This is your angle always at the origin. So cosine is negative root 7 over 4, which makes secant negative 4 over root 7, or negative 4 root 7 over 7. And what was this? Negative 3. And tangent is positive 3 over root 7, or 3 root 7 over 7, because the negatives cancel. And then cotangent is root 7 over 3. All right? Pay attention to the negatives. Pay attention to the negatives. All right, who else? What else do we have to do? Come on, people. Take advantage of the opportunity. Which one? 25?
Yeah.
How large is an angle determined by a 2/3 clockwise rotation? So we're going to go 2/3 of the way around clockwise. Now remember, angles start here. And if we're going clockwise, what does that tell me about my angle? It's negative. So my angle is going to be negative because of the clockwise. And then it's going 2/3 of the way around. Well, in degrees, all the way around is what? 360. Well, in radians it's 2 pi, in degrees it's 360. So if I'm doing it in degrees, I'll just take 2/3 of 360. Isn't that what 2/3 of a revolution is going to be? So that'll be negative 240. Now, if I'm doing it in radians, then it'll be 2/3 of 2 pi, which is 4 pi over 3. Now, it's still negative because the clockwise part tells you you're going down, so negative. Okay? All right, who else?
Could we look at 26.1?
A bird in the top of a tree is looking at a worm on the ground. So here's the bird, here's the worm, and the angle is 18 degrees 12 minutes. And we want to find the height of the tree if the worm is 123 feet from the base of the tree. Does that picture seem okay? Sine, cosine, or tangent? Tangent. So tangent 1812, we know how to put that into our calculator, equals x over 123, opposite over adjacent. So x equals 123 tan 1812. So 123 tangent 18 second angle degrees 12 second angle minutes. 40.44. Feet. 26:2. Aubrey is walking at a pace. For the Math Hall of Fame. Alright, so here's the Math Hall of Fame. Here's Aubrey. At one point, her angle of elevation is 11 degrees. After 15 more minutes of walking, so she's walking toward the building, her angle is 13.5 degrees. How tall is the building? Now, we do know that she's walking 3 miles an hour. Yep. We do know she's walking 3 miles an hour, right? How long did she walk? In getting from here to here, how long did she walk? 15 minutes, which is a fourth of an hour. So how far is this? Three miles an hour for a fourth of an hour. Guys, what if she went a whole hour? How far would she go if she walked for a whole hour? 3 miles. What if she went half an hour? 1.5? So she went a fourth of an hour. 0.75, yep. Miles. That's miles now. So she walked 3/4 of a mile. You know, back when you were like in 3rd grade, you learned distance equals rate times time? Yeah, rate times time, that'll give you the distance. Okay, I need to know how high the tree is. I'm not going to be able to do this without throwing in another variable. So I'm going to write 2 equations. We've done this before. We're going to write 2 equations. One of them is going to be for the little triangle, and one of them will be for the whole big triangle. So for the little triangle, I can say tangent 13.5 equals x over y. And for the big triangle, I can say tangent 11 equals x over 0.75 plus y. Now, what do? We've done a couple of these. What do we do now? What do we have to do? We have 2 equations. So what do we have to do? So, yeah, somehow we have to substitute and eliminate. That's how we solve a system. So if we get x by itself, it'll be y tan 13.5. And if we get x by itself here, we're going to multiply the 0.75 plus y over to this side. So it's going to say x equals 0.75 tan 11 plus y tan 11. So we wrote a tangent equation for the little triangle and a tangent equation for the big triangle. Solved both of them for x, got x by itself. Now what? Set it equal to each other. So now we have y tan 13.5 equal to 0.75 tan 11 plus y tan 11. Okay, how do we go about solving something like that? Put the y's on the same side, so we're going to bring this one over. So we have y tan 13.5 minus y tan 11 equal to 0.75 tan 11. So we set our 2 equations equal to each other, and then moved all of the y's, or whatever the variable is, we moved them all to the same side. Now what? Factor out the y. So instead of having 2 now, you're only going to have 1. So take the y out. And then it's going to be easy. If you want to get y by itself, all you have to do is divide by the parentheses. So when I divide by the parentheses, I'm gonna have y equal to 0.75 tan 11 over that parentheses, tan 13.5 minus tan 11. Normally I wouldn't write those parentheses in there when I divided, but I have to put them in on my calculator, so I'm gonna do that. So 0.75 tan 11, close those parentheses, remember these have to be closed, divided by parentheses, tan 13.5 close, minus tan 11 close. I got 3.19. Is that what you got? And that's absolutely wonderful, except it's not the answer, because that was y. So now I have to go back, and I like to use the little equation right here. I know that x is my y value times tan 13.5. So I'll just take what's on there times tangent 13.5. And I get 0.77 basically. And the unit on that is miles. So we have another tall building. It's 3/4 of a mile tall. All right, we still got time. What else? 24 you can cross off. You don't have to sketch the inverse functions.
Okay.
15. Cross these off. 15 says, in which quadrant is the sign negative, less than 0, and the cosine positive? Now, this is an easy question if you remember one thing. Sine is y and cosine is x. So basically this question is simply saying, where is y negative and x positive? Where does that happen in the coordinate plane? Quadrant 4. So the answer to the question is quadrant 4. Cosine is x, sine is y. I gotta be careful. Cosine is associated with x, sine is associated with y. They aren't exactly the same thing.
For the last one, what was the answer?
0.77. And then the very last one was quadrant 4. But that one was 0.77. Did you not get that?
I did, but I don't, we were trying to find out how tall the building was, right?
Yeah.
So it's miles.
Yeah, I know, I made it up. Yeah, it's 0.77 miles. That's the unit in the problem. That's what we used for the number 0.75, so it would be miles. You could change that into feet if you wanted by multiplying that by 5,280. But it's still kind of a ridiculous problem, but it's because I made it up. Okay, who else?
How about number 13?
13. Name two angles coterminal with negative 21. So it doesn't specify if they have to be positive or negative. And there are infinitely many coterminal angles. So we're just going to take negative 21 and add 360, negative 21 and subtract 360. And then if we want more, we can add another 360 and subtract another 360. And if we want more, we can just keep doing that. You find coterminal angles by adding and subtracting revolutions. So since that's a degree, we'll add and subtract 360. The one right under it is a radian. So we would do the same thing, but instead of adding and subtracting 360, we would add and subtract 2 pi. Yep. Okay. All